Digital Switching Systems proudly presents our continuing series of webinars to help keep our customers informed of the latest innovations in digital switching. Hi, my name is Tim Sweet, Vice President of Operations at Digital Switching Systems. Thank you for your interest in the webinar called Introduction to Multiplexing. Our topic will be an overview of multiplexing with an emphasis on the Omni-BUS product family by Digital Switching Systems with its decade of experience and capabilities. We will start the webinar with an introduction to Omni-BUS, describe some of the Omni-BUS components, look at multiplexing and how it is applied, and show some examples of large and small systems. Then we will explore some of the features available using the Omni-BUS technology and review the benefits of multiplexing. We will end by highlighting some of the new products. DSS has been shipping solid-state load control products into the market since 2004 and has developed the expertise to design systems to meet the most demanding applications. We are the leaders in ruggedized user input devices that now support multiple protocols. The DSS product has been in the market for 10 years now, with close to 150,000 systems operating in the field, from Europe to the Americas to the Asia-Pacific region. There are three main component families that comprise the Omni-BUS system. The OmniBUS brand has several families of keypads, from Relegendable to fully custom keypads. There are two families of solid-state load controllers with up to 21 outputs and can drive over 20 amps per circuit, as well as a series of electromechanical products. Gateways and interface devices which allow discrete switches or other protocols to communicate on the network round out the portfolio of products. For today's examples, we will focus on a 10-position keypad, the PowerKey 1000, shown here in one of several variations, and a PowerCore 210 load controller with 21 output circuits to demonstrate several multiplex applications. All multiplex systems consist of a bus network which communicates between components of the network, some form of input device which translates events such as a button press into a serial network message, which is then transmitted to the logical controller, in this case a load controller in the system. The Omni-BUS load controller combines both the logical features of the system with the actual switching of power. Using solid-state technology and electronic messaging enables load control features such as remote resetting of trip circuits. This provides the capability of mounting the load controller close to the power source and output devices. An example of a multiplex system installation includes the mounting of the keypad in a dash panel. Next, the load controller is installed in a compartment out of sight, typically near the power source, a battery or engine alternator. Next, the network bus is connected, which is a two-wire differential pair with a set of power and ground wires. And last, the devices or loads are connected to the load controller and the battery is connected. The operation of the system begins with the press of a key for the desired circuit. A simple example of how a multiplex system operates is as follows. The desired key is pressed, in this case, the anchor down key. The keypad translates this event into a digital signal that is transmitted over a noise-immune, error-detecting bus protocol to the load controller. The load controller, or power hub, translates the digitized event into the switching of the targeted output based on the system's programming. The power is switched on, and the device, in this case the anchor windlass, turns on as the button is held down. This is called a momentary function. Another example turns on a pump. The desired key is pressed, a digital message is sent over the bus, the load controller reacts to the message based on its programming and turns on the correct output. And the device, in this case a water pump for the shower, turns on. A press and release of the key turns the shower on, and a press and release turns the power off. This is a toggle function. Let's review the elements of a simple multiplex system. It contains a user input device or keypad which communicates over a bus structure with the logic controller, in this case a logical load controller or power hub, which is connected to the battery or power source and switches power to the various devices based on its programming. A more complicated system may contain 2 or more input devices, an interface or gateway device, a communications bus or network, and 2 or more load controllers, which may control multiple clusters of devices. Examples of how the OmniBUS system scales are highlighted in this presentation of 2 boats. A small runabout versus a cruiser will have different loads or devices located in different places in the vessel. From the top view, both boats may have common devices such as bilge pumps, blowers, horns, and navigation lights, but the larger boat will have more devices including cabin lights, fans, heaters, etc. The smaller system connects the devices using a single load controller and may have only a single keypad. The larger system will have a second or third load controller for the cabin features and may have multiple keypads to control common devices from a single helm station and more dedicated keypads in the cabin area. With a decade of experience in the multiplex business, the OmniBUS brand provides an array of features that are standard offerings with our software. We will start with a few examples. The solid-state family of load controllers uses remote trip resetting to re-enable all circuits that have been overloaded. Once the fault has been cleared, the key is pressed for 6 seconds, and the circuit is reset and ready to be used again. This enables the load controller to be located in remote areas close to the power source and/or the devices, reducing wire runs and wire thickness. Another standard OmniBUS feature. All OmniBUS keypads are backlit enabled and can be programmed to come on for nighttime applications. All keypads are IP67 rated and can be operated underwater. The DSS family of keypads have custom artwork to suit most needs. They come in a variety of shapes and layouts and can be painted to match most panel color schemes. One of the features of the DSS system is the use of the AutoSense feature. A keypad can be used to control a bilge pump, for example, with manual control. When the bilge pump is off and the float turns on the pump automatically, the LED will display the pump is in use. An H-bridge is used to control reversible motors. In one direction, the anchor is extended. Pressing the opposite button reverses the motor and the anchor is retracted. Timers can be used in multiple ways. A light can be set to turn off after a set period of time when a key is pressed or is triggered by another event. DSS, using solid-state devices, can provide pulse width modulation to perform dimming, as well as speed control for fans and other motors. DSS has a new module now available that enables a wireless key fob to control up to 4 circuits. A simple learn mode allows the user to program any key into the memory of the feature. These are just a few of the many features available with the OmniBUS system. Momentary, toggle, keyless entry, and a host of other features are available in the DSS software library. The value of multiplexing comes primarily with the replacement of discrete switching. This requires that each device be connected to the power source through the switch located at the dash. Each device, no matter where it is located, must be wired from the battery to the switch on the panel and finally to the device. A multiplex system allows connection between the battery, the load controller, located near the battery and the device, and the keypad is mounted at the dash without physical connection to the device. The most visible improvement with the multiplex system can be demonstrated when the dark side of the dash and the spaghetti fuse block are transformed from this to this. A simple bus structure joins a series of keypads to the load controller, and termination to the network devices are IP67 sealed connectors, allowing ease of installation and removal. OmniBUS is the leader in low-cost, high-quality, feature-rich multiplex solutions. Our products contain more features per unit cost than any of our competitors. The OmniBUS multiplex system is scalable, meaning it can expand easily and provide multiple command points from the flybridge, helm, or nav center, all controlling the same set of devices. And with Omni-BUS's parametric data capabilities, the system is able to monitor, control, and conserve power in almost any application. All of these features are built into the Omni-BUS product family. Add-on modules are not required, keeping the system's cost low. Looking ahead to new products coming to the DSS portfolio. Our next generation load controller, the PC14, will support multiple protocols and will be scalable from 14 to 26 outputs using add-on modules. It can achieve a cost per output that is competitive with rocker switches. DSS, with its Omni-BUS brand, is the leader in open protocol connectivity, enabling plug-and-play capabilities with displays and other networked devices. We are committed to NMEA 2000 and support both OpenCAN messaging and the J1939 protocol. The network devices can share command, control, and systems data to integrate various systems on the vehicle. The PowerKey Pro is our latest development in ruggedized keypads. It has been developed to support multiple protocols in both CAN and RS-485 networks. The keypad was launched with approximately 100 graphical icon inserts, and the keys can be reconfigured using a simple PC-based GUI. The indicator ring allows orientation of the keypad in both a horizontal or vertical mode. The new PowerGate 1000 can interface to 10 analog switches and communicate in CAN as well as RS-485 networks, including NMEA 2000. The PowerGate 1000 allows conventional rocker switches to be integrated into a multiplex system, and there is still more to come. Our portfolio of products and features continues to grow. To summarize, we have demonstrated the capabilities of multiplexing and its value proposition. The Omni-BUS portfolio of products have been demonstrated in the field to be both rugged and reliable. The Omni-BUS brand of systems components are both flexible and scalable and can be upgraded using our bootloading feature. With more systems in the field than all of our competitors combined, we have the widest variety of proven features. We are committed to an open protocol, and we continue to be the industry leader. Thank you for your time. If you have any questions or comments regarding the presentation or Omni-BUS in general, you can send them to tsuite@digitalswitchingsystems.com.